I'd like to welcome you all to this webinar about the industrial PhD student call and about the industrial postdoc call in WASP. My name is Carl-Erik Orsén. I'm from Lund University, and I'm also one of the co-directors of WASP. So here you see the program. First, Danica Kragic from KTH, another WASP co-director, will give an introduction to WASP. Then we will have a general presentation about the industrial PhD student program by myself, and then similar thing about the WASP industrial postdoc program. And then Daniel Axehill will talk about the graduate school, and then we will hear perspectives from industry from Senzact, where Christopher Pettersson and George Hess will talk about their experiences. And then there will be a Q&A session afterwards. You should be aware that this webinar is being recorded. So if you have any problems with this, you have to act appropriately. Okay, so Danica Kragic.
Thank you so much, Carl-Erik. I'm so happy to see so many with us here today, and great interest for various types of initiatives that WASP has. And to give you a little bit of an idea about who we are and what we do and why we would like to have you on board, I have about 15 minutes. And then, of course, you can ask me questions at the end. I will be with you for the rest of the webinar also. So we started as 5 founding universities, and then since the program has been going on for almost a decade now, or around a decade, we have also a couple of affiliated groups of excellence, and you can see those universities here. So WASP continues to grow. Next, the vision for the whole program has been to perform and conduct excellent research and build competence in artificial intelligence, autonomous systems, and software for the benefit of Swedish society and industry. And we have lived with our mission, and I think that we are fulfilling it, to build a world-leading platform for academic research that interacts with leading companies and actors in Sweden to develop knowledge and competence for the future. And I think that both vision and mission give you an idea of why industrial collaboration is of so huge importance for us in the program. Next. To give you a little bit of numbers, so now the budget for the program is around 6.2 billion Swedish crowns, and we have funding approximately until 2031. And the idea is that by the end of the program, together with our industrial partners, we will have around 60 graduated PhD students in total, maybe even more. And also we are on a good way of actually fulfilling the requirement of 80 faculty recruitment, so 80 new research groups to Sweden. Next. So if we think a little bit about what are WASP top research challenges in the 3 areas that I mentioned, AI, autonomous systems, and software, we conduct research in dealing with complex data and models, very much from the perspective of theoretical, but also applied AI. Next, I think we'll look into how human in the loop can be used and facilitate the explainability of the models we develop. Then we have research that addresses scaling and distribution of various types of resources. Here we talk about hardware used for computation, but also the fact that we are deploying most of the systems or models that we develop on real physical systems. Next, an important aspect is, of course, everything that we develop needs to be efficient, verifiable, secure, and robust. And again, the reason is that we are thinking about deployment of the technologies in real life systems, both when it comes to research that we do, but also research together with our industrial partners. And I think that was all regarding the research. Now we'll look a little bit into what are the instruments. So what have we built in the program in order to implement these? We have then a big focus on both basic and applied research, and I think that this is very important to say. We have built a fantastic graduate school that you will hear a little bit more about, because we also want to show and bring together PhD students from different universities, but also show that as a part of the whole WASP program, the faculty also has an important terms of like teaching and finding ways of showing how research is also important for education at the PhD level. Recruitment, I have said a little bit about, and we recruit at all academic levels, from assistant professors to full professors, in order to find ways, new ways, and also exploit the full, I would say, scale of bringing research closer to society and collaboration with industry. We have built so-called VARAs, or WASP research arenas. We have a couple of those that are also topical. We work very much on internationalization, both in terms of having various types of collaborations with universities worldwide, in order to also allow our students to, during their PhD or even after, find ways of go abroad and then potentially come back if that's of their interest. And we have a fantastic administration office that helps us to do all the daily business, where we also find that the communication events, such as this one, are of extreme importance to show you what WASP is actually doing. Next. So as we are right now, 2024, we have out of 80 so far conducted 64 recruitments. We have 440 active PhD students, out of which 122 have defended. And we have around 80 affiliated companies and agencies that are engaged in the program. So this is just one of the photos from our WASP Winter Conference 2024 held in January, where we had around 550 participants from the program getting together and for 2-3 days discussing and collaborating. Next. So given the numbers, what we have right now is approximately 1 PhD per week, and I think that that's fantastic, just to put it a little bit in different numbers. And maybe this was my last slide. No. WASP is big, but through collaborations with other strategic initiatives from the Knut and Alice Wallenberry Foundation, we are again finding new ways of deploying and testing our research in other areas. These are cybersecurity, and then we have WISE, which is an initiative in the materials science, and we have DDLS, data-driven life sciences. So what we are looking into is how then the methods can basically boost the development in the area that maybe more classically haven't been areas that hardcore WASP researchers have been involved in. And those collaborations are on the way, and we have lots of funding also available for collaborative projects in these. Next. So I mentioned research arenas. We have 4 ongoing ones: public safety, media and language, robotics, and operations. So I'm not going to say too much about those or much more about those today. But what I think for all of those interested, and especially for those that are just on the way to be or become a part of WASP, look into our web pages to understand a little bit more what the topics of those arenas are and how you can potentially engage or contribute to the research conducted. Next. Internationalization, I also mentioned. I think what is important here is that we are focusing on Europe, US, and also Asia. So we have ongoing collaborations with Stanford, Aalto, Berkeley, MIT, and NTU, organize annual trips for our PhD students, and students really love that. We also have a possibility to finance for PhD students a semester abroad. And then we also have postdoc programs that allow WASP students to, after finishing their PhD as a part of WASP, to also spend some time at one of these universities. So what I think is important in these days where everybody is talking about large-scale models is that we have also built a fantastic AI resource for our researchers that I know most of the WASP faculty, but also some people outside WASP faculty is using Berzelius. And I think that since it has been fully utilized since I think April 22 or something like that, we have demonstrated and helped with development of, for example, GPT SV3, so the Swedish GPT model. We have done lots of research regarding protein folding, also together with our DDLS colleagues. And most of the research, I would say, that currently in Sweden is done in the area of computer vision, and that deals with large-scale data is being processed at Berzelius. Next. I think that was all from me.
Thank you very much, Danica. I think, you see, we have a Q&A session at the end, so I suggest that you save your questions for that, unless they are very short. Okay, so now we switch over to the first call, the call for industrial PhD students. And first, some general words about Swedish PhD education, because some of you might not know it, although most of you do. But anyway, a Swedish PhD takes 4 years if you do it at 100% level. But normally it's done at 80% level and then takes 5 years, because the 20% then you spend, if you are a university PhD student or academic PhD student, you spend it on teaching, being a TA. And if you are an industrial PhD student, you typically spend 20% of your time working for the company doing non-research related tasks. So 5 years, that is what it takes. The 4 nominal 100% level years, so to say, corresponds to 240 so-called high school credits. And depending on which university and which department you are enrolled at, you have to take somewhere between 60 and 120 points of courses, PhD student courses. I would say that most today are probably 90, between 60 and 90 somewhere. And 90 corresponds to 1.5 year of full-time studies. And that is part of the PhD exam. Normally the departments, they require that certain mandatory courses are included in these 90 credits. And WASP also requires that out of the 90 credits or 60 credits or whatever, 27 credits should be among the WASP mandatory courses that are given by the WASP graduate school. So that also means that most of the courses that the student takes, they are not WASP courses. They are courses given by the local department and local university. And the rest, apart from the courses, is then what constitutes the research and the writing of the PhD thesis. An industrial PhD student in Sweden and in WASP is employed by a company and perform the PhD studies at a university department that belongs to a WASP university in our case. And this takes then 4 years, as I said, if you do it full time. But in the normal case, it takes 5 years. And for this, the company receives 600K Swedish kronor per year from WASP if the studies are done at full time, 100%, or if it's done at 80%, the company receives 480K per year. And this money should include a travel budget. And when I saw this slide, it said 30K per year, but I actually think it's 40K per year. That is the travel budget, because that is the travel budget for the academic university PhD students. And it's very important that the student is allowed to travel. Also, for instance, if the company has a travel ban. So even if the company has a travel ban, the student that is employed by the company still should have the possibility to travel to conferences and to go on study trips. And WASP have certain mechanism to ensure this. Then the university and the academic advisor also gets certain amount of funding from WASP for doing the supervision of the industrial PhD student, and that corresponds to 50% of the salary of the supervisor. Then the PhD student has the university PhD advisor, which normally is called the main advisor, and an industrial PhD advisor, someone at the company. And ideally, this should be a person with some research experience. Again, ideally, someone with a PhD, or with a lot of experience of supervising master's science thesis and so on. Then the rule is that the PhD student must spend at least 20% of the time physically at the university and at least 20% at the time physically at the company. However, spending only 20% of the time at the university, that's not enough. In practice, it has to be somewhere close to 50% at least, I would say. Then there is a contract that needs to be signed between the company and the university, but there is no contract between the company and WASP. Then, as for all PhD students, there should be an individual development plan, so-called utvecklingsplan, that is being held up by the university, and that should treat things that are no, sorry, this now there should be a plan also for the industrial part of the project. Who is the main contact person at the industry, the industrial supervisor, the role of the closest manager, the role of the project in the overall company strategy, and so on. So there should be an industrial development plan. But then at the university, there will also be an individual study plan, and that is what all PhD students have. That details issues such as time spent, research results obtained, conferences attended, and things like that. So companies involved, we have around 100 active industrial PhD students from around 80 companies. Of the 122 or so PhDs produced by now, 31 are industrial. There are some companies with a very large involvement. The largest one is Ericsson, but also Saab and Sensact, which you will hear about later. ABB and AstraZeneca have several industrial PhD students. But the majority of the companies only have one PhD student each. There is also a rule that says that research institutes, for instance, RISE, and public organizations, they may not participate in having an industrial PhD student. One should be aware of that WASP not only reaches out to the traditional Swedish system industry, but also to other branches like finance, media, consulting companies can participate, health, and so on. So there is really no constraints on the type of companies that may participate, except this for research institutes and public organizations. So this call that opens the 10th of June, here we will fund up to 15 projects. Normally we say 15 positions, but this year it's a bit different. So in this time we will fund projects and not positions, and I will come back to that very soon. So the call opens 10th of June, and there is the application deadline 1st of October, 2 o'clock Swedish time. Then the decision by the WASP board will be communicated to the applicants the 6th of December after the board meeting. The earliest start date for the PhD is 1st of January 2025, and the latest start date is 15th of June 2025. You submit your applications through the WASP application portal, and there is a link to this portal. And there is an application form there that you should use. By the way, you will get copies of all the slides, or actually, the copies of the slide will be put on the WASP homepage afterwards, and also the recording of this presentation. I got a question. Does public organizations also include NFC and FOI? I'm quite sure it includes FOI. I'm not even sure what NFC stands for, but I think so. But questions like that, I suggest that you send us emails and we will check it in detail. National Forensic Center, I guess so, yes. The application should be signed by both the academic and the industrial supervisor. So it's the university and the company that together writes the proposal and signs it. So it's a joint effort, this. What's new this year is that instead of positions, we fund projects. And you can either apply for a 1 PhD student project or for a 2 PhD student project. But you may only apply for a 2 PhD student project if at least one of the 2 candidates is of the underrepresented gender. And we count that on the WASP level. And on the WASP level, it's females that are underrepresented. So we want to raise the number of female PhD students in WASP. We actually have a KPI that says that by 2030, we should have 40% female PhD students. So if you have a good female candidate or 2 good female candidates, you can consider if you should apply for a 2-student project. And if you do that, the 2-student project proposal should clearly describe the role of each of the students in the project and how the 2 students complement each other. However, a 2 PhD student project is either accepted fully or rejected fully. It cannot be the case that only one of the 2 candidates is accepted. And that means that you have to think through in detail if you really should apply for a 1-student project or for a 2-student project. Let's say that you have an excellent female candidate that you know will be accepted. And then you have a male candidate that is not so good. Then I would go personally for a 1-student project, because there would be a risk that the not so good male student can crash the total proposal. So you have to think that through how you should do. And then each industrial supervisor may submit at most 1 application. So you cannot, so to say, double your chances by writing one student project and 1 2-student project proposal. So that's the new for this year. We'll see how it turns out, if we get any 2 project proposals or not. Okay, then WASP. What is WASP? Well, as you know, WASP is split up in different parts. We have autonomous systems, AS, we call it. And in autonomous systems, there is research on autonomy as such. But for most, I would say it is research on enabling technologies for autonomous systems. So perception, interaction, visualization, human-machine collaboration, multi-agent systems, robotics, autonomous clouds and networks, cybersecurity, localization, large-scale optimization, and so on. What's common for the projects in the autonomous systems area is that they have a strong systems focus. Very often they are based on data-driven techniques, but they could just as well be based on more traditional model-based, non-machine learning-based approaches. So many believe that WASP is only about AI and machine learning. That is not the case. There is quite a lot in WASP that is not at all about AI and machine learning. Then we have the AI part of WASP, and that is split up in two parts. We have the so-called MLX part, that stands for machine learning, deep learning, and next generation or explainable learning. And here the focus is much more on method development in machine learning, I would say, with the aim to publish at the top international conferences in machine learning like ICML and NeurIPS and similars. Then we have the math part of AI, and that contains two parts. The first one is the mathematical foundations of AI machine learning. And here one tried to fund projects which can use math techniques to prove why machine learning, for instance, deep neural networks, are so good as they really are in many cases. Why do they generalize so well and so on? To try to use math techniques to explain that. And then we also have the theoretical computer science foundations of AI, which is considered part of this. And that is things like, planning problems and formal methods problems and so on. These types of things are considered part of the math part of AI. Then we have the software part. Software methodology and software technology are both included. And it is either software for the modeling, analysis, development, etc., of autonomous or AI and machine learning-based systems. So using software for developing or analyzing these types of systems, or it is software that contains or utilizes the WASP techniques in autonomy, automation, AI, learning, feedback, and so on. And then finally, 2 years ago, the foundation decided that the WASP should also spend special funding on cybersecurity. And also here it should be cybersecurity that somehow is related to the other parts of the WASP. So what do the autonomous systems and software students actually do? Around 7-8 years ago, I did a word cloud of the titles of all the projects in autonomous systems and software, and I got this result: autonomous control system network, but also learning and so on. And then I did the same for the AI students, what they do: model learning, deep networks, reinforcement, supervised, so on. This was, as I said, 6-7 years ago. If I had done the same thing now, I'm quite sure that the big thing here in the middle would have been generative AI, something based on that. Transformers maybe, which is very popular in the AI part of the WASP right now. Okay, so what are the evaluation criteria? And in general, there are 3 criteria that are evaluated: the project, the PhD student or students, if you have a 2-student project, and the supervisors. For the project, it should be scientifically excellent. It should be have some unique, visionary, and novel nature. It should, of course, be relevant to WASP. And it should have some potential to collaborate with other initiatives in WASP, such as the WASP research arenas, the VARAs. PhD student candidates, since the evaluators don't have interviews, we don't meet them and so on. The main thing that one can have a look upon are the CVs and the grades from the master education. And then the supervisors, their scientific merits, international research experience, pedagogical skills and merits, shown ability and experience of collaborations between academia and industry, and then also constellations where the underrepresented gender is involved, they are encouraged. So PhD student and supervisor or supervisor that is female are encouraged. And then I should say that the industrial PhD student instrument, as we call it, that is primarily aimed at students who are already employed at the company. Ideally, they should have worked for the company like 3 to 5 years maybe, and gained all the experience from the company, so they know what the business ideas are and what the problems are and so on. But it could be that some small companies, often in the AI branch, they might not have any internal candidates to put on a project like that. And in that case, it is possible for them to employ a student candidate, especially for this position. But the candidate must be identified and named at application time, but need not be employed until the latest start date of the project. In this case, there is, of course, a risk that the student decides to quit after the proposal has been accepted, but before the latest start date. And if that is the case, the company is allowed to propose a new PhD student candidate if that candidate has at least as good qualifications as the original one. If the student decides to quit after the start of the project, then the project will be terminated. So what are then the elements of a good proposal? Well, it should fit into WASP. It should have a clear and well-described scientific problem or research questions. There should be a novelty aspect in it. And one should try to focus on explaining why the applicants are the best suited parties to address this problem, how they complement each other and so on. And then, of course, the added value of this project to academia, industry, and Sweden as such. But above all, I would say, the main requirement is that you have a strong PhD student candidate or candidates. By the way, if you apply for any project, you cannot send in the list of suitable student candidates and say that you haven't decided yet. You have to decide when you send in the application. Okay, more information you get. If you have general questions, you mail it to info. If you have more specific questions that are more local in nature, you can contact your different WASP University representatives. So Chalmers, Robert Fält, KTH, Bo Wahlberg, Linköping, Mikael Felsberg, Lund, myself, Luleå, Marcus Lewicki, Umeå, Erik Elmroth, Uppsala, Thomas Schön, and Örebro, Emil Lutfi. Some general further questions. So how should we define the project topic? Well, the project topic should be sufficiently long-term so that the results still are of value to the company after 5 years. Remember, this takes 5 years for the PhD thesis to be ready. Of course, there can be results that you can spin off already earlier, but the main results won't be available until after 5 years. And then the project topic should have sufficient research depth to allow publications. I mean, publications, that's the way researchers communicate with the world and demonstrate what they have been doing. How should we handle deviations? It is the case that very few students end up with a thesis that is exactly about the problem that was initially formulated. And there are many reasons for deviations. It could be that the initial problem is too easy or too difficult or maybe not interesting anymore and so on. So there are deviations and you have to be aware of that. It's not something strange or wrong that things deviate. What is then a good PhD student candidate? Well, as I said before, an ideal candidate should have a couple of years of experience of the company, but still have the graduate education, the master, fresh in mind. But as I said also, WASP accepts industrial candidates also if they have shorter and also longer experience. That can happen. Ideally, they should have very good analytic competence. They should be good at problem solving. They should be good at communication, both orally and on written form. And they should have good grades. And in particular, in the courses of relevance to the project and of relevance to WASP. And they should also have in mind that many of the WASP courses, they are rather mathematical in nature. Not all, of course, but I mean, a student that is not at all interested in math and have very low grades from the master in math courses, that is probably not such a good idea. What is then the objective for the company? Well, it could be to initiate a long-term collaboration with some leading research group in order to improve the company's innovation capacity. It could be to solve fully or partly some challenging, important problem for the company. It could be more generally increase the knowledge within an area that is of relevance. It could be to focus on one very promising employee and try to do competence build-up for that employee. Or it could be to obtain persons with sufficient skills to take some leading R&D role after 5 years in the company. But there are also other reasons, other objectives for the company to become involved in this. But it's important that the company is aware of the realities of PhD studies. That 1.5 years is spent on taking courses. Some of the courses may be of less interest to the company and to the student, but they must still be taken. An important part of the studies consists of travels to conferences, summer schools, study trips, meetings, and so on, where the student discusses, presents, and learns new things. And the student must have the possibility to travel also if the company has a travel ban. How should one guarantee that the student remains relevant to the company during these 5 years? It could be a good idea to have a shadow project within the company where the PhD student is involved and where intermediate results can be evaluated, and also when new research questions can be generated. Then it's also often a good approach to try to formalize the knowledge transfer by having, for instance, regular presentations by the student at the company. So they learn what the progress is, they learn what the topic and the problems are, and so on. And then finally, well, not finally, but how can we be sure that the PhD stays with the company afterwards? Well, there is no easy answer to that. You cannot. Among the industrial PhD students that we have had and that have graduated, most have stayed at the company, but not all. Some of them have switched company. Some have gone to universities and so on. How do you start? Well, you start by identifying the PhD student candidate and the academic supervisor. And if you don't have contacts in academia yourself, then you should ask the WASP university representative. And normally you contact the one that is geographically closest to your company. And then you start the discussions with the academic supervisor as early as possible, because the academic supervisor normally knows best which research problems that fit into WASP and which that do not. There is also a quite good report that we did already in 2019 about industrial PhD students in general, things to think about and experience and so on. So that you can download. Okay, that was the industrial PhD student program. I think we can take a very brief question if you want now. I'm actually exactly on time. Impressive. No questions. Okay, then we go on with the industrial postdoc program. And this is something we started last year. And this mainly targets newly graduated PhDs who haven't decided if they want to do an industrial career or an academic career. It also enables the hosting company to get to know the postdoc and at the same time conduct a 2-year academic project. It is the hosting company that apply together with a university research group, and there should be mentors both at the company and at the university. The key priorities are industrial relevance and academic quality. The postdoc will be employed by the company, but the time should be shared between the company and the university, nominally 50-50, but we also say that at least 50% of the time at the university and at least 20% of the time at the company. The main target is newly graduated PhDs, but it's also possible for candidates with an older PhD exam to apply. So if you have some employee at your company that did his PhD 10 years ago and that would like to further develop, you can apply for one of these projects for him or her. And it's also so that the PhD doesn't have to be performed in WASP. It can be outside WASP. It can be before WASP even was thought about. And as I said, the projects are expected to address fundamental research problems with industrial relevance within any of the WASP research areas. The total grant over 2 years is 2.2 million Swedish kronors, out of which 300K goes to the university for supervision and so on, and 1.9 million go to the company for partial salary funding. And if you are an SME, small or medium-sized enterprise, the total grant is slightly higher, 2.7, and 2.4 of this goes to the company. And we will fund up to 5 positions, same as last year. And this is 1 postdoc positions. 2 postdoc positions doesn't exist. There are a lot of rules. I said for the it should be at least 80% of full time. So you cannot do this postdoc on half time or something. At least 50% of the time at the university. And the research should be at the level that it can be published in a scientific journal or conference. And this holds for the entire project, also the part that is performed at the company. Patent applications are not considered as scientific publications. For the company should be sufficiently large to be a suitable host for an industrial postdoc. And that means at least 2 to 3 full-time employees. I personally think that that is on the low side. I think there should be more, actually. And then there should be an academically competent supervisor or mentor at the company that works with research or research-related tasks. For the industrial supervisor or mentor should have sufficient academic competence. It cannot be the same person as the university supervisor or mentor. And the industrial supervisor or mentor should not have been the postdoc candidate's supervisor during his or her PhD. For the university supervisor, can be involved in the company, but not as the CEO. Can own parts of the company, but not be the main owner. And for the industrial postdoc, he or she can be involved in the company, but not as the CEO. And can own parts of the company, but not be the main owner. And in general, if you have some personal relationships between the applicants and the candidate, or between the 2 applicants, or if you have some business relationship, you should be careful, because we might have missed some cases in this rule list above. And we might still say that this is not allowed. So if you have some situation like that, then you should contact us before you start writing your proposal to see if this type of relation is okay or not. What the WASP is afraid of, and it has to do with the fact that the foundation is afraid of, is that the money is used for direct industrial support, and that is not allowed according to the statutes of the foundation. So that is the main thing. And when we had this call last year, we had 10 proposals, 5 of them were accepted. But the ones that were not accepted, it was all the time because of strange relationships between the advisors and the candidate and so on. So be very careful about this. Evaluation criteria. The academic qualifications of the industrial postdoc candidate must, of course, have a PhD, the industrial relevance of the project, the scientific level of the project, the industrial and academic qualifications of the industrial and the academic supervisors, as well as their potential to support the candidate and the project. And then mobility. To what extent the candidate has changed research group between the most recent university appointments and the planned industrial postdoc. So mobility is good. If you send in a proposal where you have done your PhD in one research group and then you want to stay in exactly the same research group, that is not so good. I wouldn't say that it's impossible, but it will in general be ranked quite low. And then for work permit and residence reasons, it may be necessary for the applicant to submit the application prior to obtaining the PhD. If that is the case, there must be a statement from the PhD advisor that tells when the defense is planned. Actually, it would be good with a date there that the defense is planned for some months or maybe even half a year ahead. Also here, you get more information by contacting any of the WASP University representatives. Timeline, the call opens 10th of June and it closes 1st of October, 2 o'clock. That is the same as for the industrial PhD. Decision communicated 6th of December, earliest start date 1st of January. Latest start date is a bit later than the PhD. It's not until the 1st of September next year.
Okay, so I will talk about the WASP Graduate School. So my name is Daniel Axel. I come from Linköping University and I'm the director of the WASP Graduate School. I share this role together with Fredrik Heinz. So let's see if you'd like to change. So the graduate school mission is to educate PhDs with skills in strategically important disciplines within WASP and also give a broad knowledge of AI, autonomous systems, and software development. So I will give you some statistics from the graduate school. And this is from January 2024. This is ticking basically every day, so it's hard to get real and up-to-date number, but there are more than 460 active PhD students, and it includes more than 100 industrial PhD students. So let's see, someone was chatting here. Is there something?
I try to answer the questions.
Yep, great. Okay, and 109 have defended so far.
122.
122 today.
Yep.
Let's see what it is when this webinar ends. So the targets for 2031 are 600 PhDs, and of those 150 will be industrial PhDs. So the goals for the students are to become knowledgeable researchers in the relevant areas of WASP, which are AI, autonomous systems, and software. The students should form a strong sense of belonging of WASP to connecting them together, and that's why networking and social activities are also an important part of the WASP program. The students should get to know Swedish industry, and this is done, for example, via VARAS, the WASP Research Arenas, and the WASP Project course. And students should also form a strong and valuable international academic industrial network. And here, for example, study trips, international study trips are very important. And students should strive for excellence. So this also means that, becoming a PhD and becoming a WASP PhD is a challenge. But I really think that it's worth this challenge, and you will get quite some reward in your continued career if you take this challenge. So the goals for the graduate school are that we will organize courses and activities to provide students with state-of-the-art knowledge in AI, autonomous systems, and software. We will organize courses and activities that respect the needs of a heterogeneous group of students that are spread out over entire Sweden. And this is a challenge for us, but it's also rewarding for you and for us, because it also gives different perspectives, and you get to learn many different persons with different backgrounds. And we will provide an added value to the students' PhD education. And for that, we have many different activities as you will see soon here. And we will provide opportunities to those that really want to excel. And of course, we would like everyone to really excel here. So the graduate school activities, they are basically, of course, courses, but there are also other activities which I will present here. So one important activity is the winter conference, and this is an annual conference where everyone in WASP meet. So the first year, this will be an introduction to WASP, where the students get to know WASP and other students, but also the supervisors, they are also invited to get to know WASP and other supervisors. We have a kickoff also for the supervisors. The second year and the other years, the students give poster presentations and they receive friendly feedback on their research. And they can also discuss feedback with their friends and colleagues. And of course, this is also a very important time for networking to build up this network for the future. Once you have accomplished your PhD, then the fifth year here, you can celebrate your accomplishments with a diploma at a very nice ceremony at the winter conference. Another nice activity that we offer is the summer schools. First year, there is a community building summer school where you get to know WASP and other students. So this is also partially serves as a similar activity as the introduction to WASP at the winter conference. It depends a little bit which one comes first for you, depending on when you start over the year. Then for year 2 and on, then there are several thematic summer schools offered where you get the opportunity to learn areas from experts. And year 2, this is expected, you are expected to attend, and year 3 and on, then it's optional. Another activity is the international study trips. There are 2 centrally arranged ones and 2 student arranged ones. So the idea here is to get new knowledge and build up an international network. So year 1 and 2, then you're expected to participate, and these are these centrally arranged ones. And then year 3 and on, these are optional, but then you can be more creative yourself also if you would like to, or join some colleagues. So finally, there are also some research stints abroad where you can go abroad and do research in a period for 1 to 6 months. And here you get the opportunity to conduct research and also network, of course. So this is available from year 3 and on, and this is optional. So I will just check in the chat if this is something that relates to me. No, it's Karl-Erik, perhaps. Okay, so then we are at the courses, which is of course a very important part of the graduate school. There are different types of courses. So first, there are some introductory courses, 2 of them. Introduction to Logics for AI and Mathematics for Machine Learning. And the idea with the introductory courses, it's basically to give a primer such that you can enter the main courses with a sufficient level. So these are voluntary. And then there's a mandatory course, which is called Ethical, Legal, Societal, and Economical Aspects of AI and Autonomous Systems. And this is then taken by everyone in WASP. Then we come to the foundational courses type, and here you're required to take 2 out of 3. And these 3 courses are Autonomous Systems, AI and Machine Learning, and Software Engineering, Cloud Computing. And then finally, we have a group of courses called Advanced Courses. So in general, you need to take at least 2 more courses than what I've already mentioned. And then many people select among the advanced courses, but it's also possible to take the last one of the foundational courses. So the advanced courses are deep learning for NLP, graphical models, spatial learning, and SRL, interaction, collaboration, and visualization, learning feature representations, learning theory, reinforcement learning, scalable data science, topological data analysis, and WASP project course. And as I mentioned before, the WASP project course is a very good connection to industry and also to the VARAs, the research arenas. So the course schedule, it briefly looks like this. So there are some yearly courses, which are the introductory courses, the mandatory course, and the foundational courses. And then the advanced courses, these are given either odd years or even years. So it's important to plan the studies such that you can take the courses at a good place in time, of course. And in particular, then those courses that are not given yearly. So, so I will clarify also the activity requirements. So there are some mandatory activities, and that is to collect these 27 ECTS or HP credits of WASP graduate school courses. 3 + 12 of these credits are mandatory and foundational courses, and there is some freedom of choice, as you saw, because it's sufficient to take 2 out of 3 foundational courses. And then there are 12 HPs, advanced or foundational courses, and here you have basically the full freedom of choice. It's mandatory to attend the annual winter conference and also attend the community building summer school the first year. And that depends on your starting date there. There's a break point. I think it's June 15, but I'm not 100% sure. So there's also some activities with expected attendance, and that's the 2 centrally arranged study trips, years 1 and 2. And then a thematic summer school, year 2. So with that, I would like to round off by saying that it's important to take this opportunity that WASP is and strive to do the most of it. As I said, it will be a challenge, but I think it will also be very rewarding, and you will get knowledge for life, but I think also friends for life. So that was everything that I wanted to say and share today.
Thank you very much. So my name is Christopher Pedersen. I work at Sensact. So I will give about 20 minutes on sort of my perspective from the role as a supervisor, and then my student Georg here will give his perspective from a student point of view. Okay, so there. So the outline of my part is that I'll say a few words about Sensact and about my own background, and mention some of the benefits you get from joining this WASP program, and to run these, in particular, the industrial PhD projects and how we set them up at Sensact. And I'll give a few examples of the kind of research questions that we have posed and how that has impacted both the research and development at Sensact. Okay, so Sensact is a software company. So our mission is to really develop world-class autonomous driving and advanced driving assistance system software for consumer vehicles. And the prime goal is really to enhance traffic safety globally. And the ultimate goal is to really eliminate traffic accidents completely. So our vision is simply a world where there are no road traffic fatalities or injuries. And we believe that we can achieve this with technology. So our main office is in Gothenburg, but we also have smaller offices in Lund and Shanghai. We're a bit more than 700 engineers, out of which 60 or 70 are deep learning engineers. And our customers are Volvo Cars, who are also our owners, and Polestar. So for myself, I started off doing theoretical physics. I did a PhD at Chalmers, aimed at unifying quantum field theory and general relativity. So after that, I moved on to more particle physics. So I did postdocs at CERN, Madrid and Brussels, more focused on developing particle physics models that could be tested in this Large Hadron Collider experiment at CERN. Then came back to Chalmers, but in 2017, I decided to switch gears completely. So by then, it was pretty clear that deep learning was going to change everything. So I wanted to work on that. And the most interesting problem that I could find that could really have a positive sort of effect on society was this autonomous driving challenge. So back then we were called Zenuity. So we been through some company split and name changes, but now we're Zenseact. So I've been a product owner also of something we call Deep Learning 2.0. So this is basically our next generation software stack where we are simply expanding the use of deep learning everywhere. So in the online stack, but also in all the surrounding parts with data curation and synthetic data generation and all kinds of areas. And now I'm work as a technical expert in deep learning, and I am the industrial supervisor for 3 of these WASP industrial PhD projects. So there's Adam in Lund with Kalle Åström as academic supervisor, Georg here that will speak right after me, at Chalmers with Lennart Svensson, and William at Linköping with Mikael Fältsberg as academic supervisor. So these 3 pillars of WASP, AI, autonomous systems, and software are really close to our heart at Zenseact. So of course, the AI part, we have all these very high-dimensional, high-resolution sensors, surround cameras, radars, LiDAR. So we do need really robust and efficient processing of all that data in order to understand the surrounding environment and also understand how it's going to most likely evolve into the future. And so for those, most of those perception and prediction tasks, state of the art are these deep networks. So that's the reason why we're really investing so heavily in this technology. And with respect to the autonomy, so one way to motivate why we really want to go towards a higher degree of autonomy is that when you look at traffic accident statistics, in the vast majority of the accidents, you can really trace the root cause, at least to some part, back to the human error. So often the driver is inattentive, perhaps watching the phone or speeding or driving under the influence. So in order to really achieve this vision of zero collisions, we do need to eliminate the human error. So therefore, these systems or these vehicles need to become increasingly autonomous. And so we are the software company, so this is what we do. So we're really developing the full stack from pixels to torque. And of course, our application is safety critical. So our software, runs in 2-ton robots with an operational design domain that involves unprotected humans. So the requirements on safety is extremely strict. So why do we need research at Zenseact? And I would say, first and foremost, developing autonomous driving software for consumer vehicles that is truly safe, robust, efficient, useful, and cost-effective has never been done. So we're looking for solutions that currently do not exist. So therefore, I think it's easy to motivate that we do need research. And our space is really, really competitive. We have competition from the car manufacturers, the hardware suppliers, software companies, and any kind of mix thereof. So it's very competitive. So for us to have a competitive product, we really need to be at that very cutting edge of these technologies. And then also we are, while we're of course take inspiration from a lot of academic research that is done in this space, we also see some challenges that or some other dimensions to these problems that you typically don't see is that well covered in academia. For example, just the fact that the kind of algorithms or networks that we are interested in, we have to be able to run them in cars. We have to deploy them, compress them significantly so that they can really run with really low latency on really resource limited hardware in the car. So that's a really non-trivial step. And yeah, just to give one more example, in terms of the data, a lot of academic research is really quite focused on like very small, very clean and nice static data sets, and then they focus on the algorithm development. Whereas the most common way that we solve issues that we find with our software is that we try to collect targeted data to solve them. So typically our training data sets are much bigger, not as clean, and they are like continuously evolving all the time. And yeah, so some of the benefits of this WASP program is, I mean, first and foremost, it really enables you to focus on some of these key, like profound challenges that you see are important to your product, to your company, maybe on a time scale of 3 to 5 years or even longer, and that you wouldn't expect a typical development team to solve that in a sprint or in an increment, but you really want a really talented person to focus fully on some particular problem for an extended amount of time. And you also want that help and that perspective from the academic research side. So both from the academic supervisor, but also more generally in this very extensive network of WASP with both academic university partners and industry partners filled with really strong researchers and engineers. And of course, if that is a key challenge, a key area that you see is of strategic importance, then of course you want to develop in-house expertise in that area. So that PhD student will hopefully grow into a world-leading expert in that specific area. So that's of course extremely beneficial from the company point of view. And then, also connected to this large network of talented researchers, there's of course a great opportunity for recruitments for the companies. So we already heard about the typical steps leading up to one of these projects. So let me just iterate that really important to really identify this key challenge that your company is facing. And then given that challenge, you want to identify the most suitable PhD candidate and academic supervisor. So our PhD candidates most often come from in-house engineers that have an interest in doing research, but sometimes they come from, we have openings, public announcement for openings for PhD positions coupled with a permanent job offer. And then I would also say that it's really key that the research question and the WASP and the application is really written and iterated upon together with the academic supervisor, because you will have different perspectives, different backgrounds, perhaps slightly different interests, and I think that is great. So it does require some iterations and alignment in order to converge on some really sharp research question. And the way we think about it is that those questions should be formulated so that you will get basically two things. So if the project is successful, if you successfully address that question, the product of the company should be better. It should really bring value to the company, either on short term or on long term. And second, if that question is addressed successfully, then when you write it up, you should have a good chance of getting accepted at a really top tier conference or journal in your field, because that's of course what the PhD student will need at the end when he or she is defending the thesis. So the setup at Sensact looks something like this. So the industrial supervisor really has devoted at least 5 to 10% work time to the project. So that should be agreed on with everyone. So it's not something that is on top of an already 100% commitment. So in any kind of, and you should of course be evaluated based on your performance as an industrial supervisor in any salary review or so, that you are evaluated based on that, your contribution to the project. And our PhD students join a dedicated team, advanced graduate program, we call it. So even though they work on very different topics, they have joint stand-ups, they have an academic coach, an engineering manager. They collaborate a lot, brainstorming, reading each other's drafts, and so on. So I think it's a very, very creative and positive atmosphere. And of course, collaborate and communicate a lot with the rest of the company. So whenever there are results or some ideas, we typically have presentations, very often company-wide. And in some cases, when it's more about integration efforts of the research, we have more dedicated like technical sessions with only those relevant development teams. So that, I would say, is one of the responsibilities of for the industrial supervisor to really continuously evaluate the possibility of integrating the research into the product side. So whenever you have an insight on this challenge that you have defined the project for, or you have a method that is really looking promising, that really starting to work, then there should be a concrete plan to integrate that into the product so that you can really leverage and get value from those insights and methods. And finally, one tip is that in particular for machine learning research, it's a really good idea to release some of the company's data publicly. So we released this Sensact open dataset last year, which is one of the largest and most diverse datasets for autonomous driving, involving our annotated sensor data from cameras and lidars. So this is really a win-win. So that enables the PhD students and of course any researcher or startup to work on our data. So that means that they can work on really real-world data set. And from the Sensact perspective, it's really great because all these research methods are being developed on our data, which means that it's very easy to understand what works and what doesn't, what we should bring into the product and so. And yeah, let me just end with just to give like 2 examples of the kind of challenges that we have identified. So the first one is this that we saw many years ago. And the question is really how to reduce the dependency we have on human labeling, on manual annotations, because that is very costly and time consuming. And in particular now when we're moving into networks that process sequences of sensor data and do very advanced prediction tasks, manual labeling then becomes really prohibitively expensive. So we have done several efforts trying to address this question. For example, one paper by Georg, and concerning training strategies that do not involve manual annotations. And in terms of impact, all these efforts have really led us to now have a full-blown development team with the full focus on like self-supervised pre-training foundation model training and auto labeling with big ensembles of networks that can process both the past and the future of the sensor data, because everything is in an offline setting, purpose to just generating the supervision signals that then the online system is trained on. Another example of such a question would be how to test our full software stack in a really efficient and extensive way when it comes to all these possible safety critical scenarios that may happen out there in traffic. So this is one of our biggest challenges, these incredibly long tails of corner cases that happen very rarely, but are of extreme importance. So doing it brute force, just trying to collect real world data, just doesn't work. You need too much data. So then you typically turn to simulation. But I would say that all the simulation approaches in automotive industry, I mean, they're all sort of insufficient. They all have some issues that you can't, for example, that they're not simulating the sensor data with high enough fidelity, or that the whole approach is simply too, it's not scalable, that it's not cost effective. So we've been running a whole line of research projects in addressing that exact question. And we have developed this state-of-the-art method that I think Georg will actually say a few more words about. And this has already been integrated into our in-house closed-loop simulation environment. So of course, there's lots of work that remains, but I think it's really nice to see that we've integrated this research even before we presented it. So we will present it at this computer vision conference in Seattle in June. Okay, so summary. So I hope I convinced you that this WASP project has really had a significant impact on Sensact's research, but also on the product development side. A lot of insights have been already integrated, and we see that it's made the product better, which means that the cars are safer, and that means that ultimately they will lead to an enhanced traffic safety globally. So this just aligns perfectly with Sensact's mission to save lives in traffic by pushing the limits of these three pillars on AI, autonomous systems, and safety critical software. And that's it for my part. So I will just hand over to Georg.
All right. So my name is George. I'm one of the industrial PhD students here at Sensact. And I will talk a bit about my background, my PhD time so far, my thoughts on how to be a PhD student and to, at the same time, generate some company value, and then some takeaways from my journey so far, how to create a happy, which I hope translates to a successful PhD student, and what the WASP program can bring to a PhD student. So short background, I did my bachelor's in mechanical engineering in 2018 and a master's in systems mechatronics and control at Chalmers. I'm also doing my PhD now at Chalmers, so I've stayed around there. So my background maybe isn't super aligned with deep learning, but I did a bunch of internships in automotive and AD development since 2018. And then my thesis on deep learning as well. So that led up to me joining Sensact in the summer of 2021 as a PhD student. And I basically joined directly from university. So I didn't work at Sensact before that. So my journey so far, I started in August 2021. And as most PhD students in the beginning, there's a lot of uncertainty, like what am I supposed to do now? I focused a lot on coursework. But after half a year, I had my first paper submitted. And I think one of the big success factors in getting a paper early is so that when I started, there was already like an idea of a predefined first project that had a pretty good chance of success. So it was a low-hanging fruit. There was a low risk of scooping, so we weren't thinking that anyone else would look at this. And the project had fast iterations, so we could see pretty early, would this lead to anything or would it fail? So I think having that in place when you take on a PhD student is really valuable, because then you get in, there's a lot of uncertainty, but you sort of know, okay, I have something to work on. So I did this pretty much solo with my supervisors, and although it was successful, I also found it quite stressful to work on my own, and there's some uncertainty. Like if you just do a project by yourself, you work on it for half a year, it fails, you stand there with no paper, and you're not really closer to a defense. So I started switching a little bit and focused more on cooperating with other people. So this is where this Sensect graduate program was really great, because then it's really easy to work with the other PhD students here at Sensect. And also supervising master thesis, you have sort of your minions working for you. And that's been a pretty successful route, I think. So it has led to a bunch of publications at different conferences. And I think since that first paper, I haven't done a single project by myself anymore. You sort of can work on multiple things at the same time and put your eggs in different baskets. I did my halfway seminar last year, and the goal is to have my defend my thesis early next year or something like that. So some thoughts about how to be an industrial PhD student. So different from academic, you also sort of have to think about what value do I bring to the company. And usually people might think there's some inherent conflicts between like the academia, where as a PhD student, I mainly care about writing papers and getting my defense done, compared to a company that wants to work on other things. A good thing with this field of like computer vision and deep learning is a lot of progress in this field is actually driven by companies. So there's actually not much of a conflict in this field. So I think that this is a really good area. And as Christopher mentioned, I think a good way to end up generating company value is to, from the start, define projects that are both useful for the company, but also have in mind that they should have this good academic impact. So you as a student have a feeling of, okay, this will actually result in a paper I can write about this. It's not just a useful project at the company. And that's where it's important that the academic and industrial parts actually work together when defining what the project should be about. Being in industry, I also think you can utilize that to find sort of new challenges that aren't addressed in academia, like Christopher mentioned, how to make it run fast, like if you only have limited compute, or trying to, rather than work on a small data set, how do you scale this properly? Beyond the project, I think it's also good to try to spread knowledge in the company. We have study circles or these company-wide presentations. So each time we finished a project, we try to sort of communicate that in the company. And that's been quite successful. So just an example of this, one project that we've done. Do these videos play?
I think you have to press one more.
One more? Okay. So one of these latest projects we've done is called neural rendering. So we take sensor data collected in car, which usually is quite boring, like we just follow a car or drive behind it. Usually it's quite uneventful. And with our method, we can create these safety critical scenarios sort of test our stack on something completely different, that some sort of what if scenario. And we had a presentation about that in the company, and people reached out afterwards. And I think it took maybe 2 or 3 weeks. A team had picked this up and actually ran this on our stack. So here we have some data that we've collected. We run our algorithms on it. Of course, our method isn't perfect, so it looks a bit blurry. Algorithm might perform differently. And then what we can do with this is we can alter sort of what happened, and look at the same scenario again, but instead of this car driving past us, we can reason, okay, what happens if it drives into our lane and it starts braking? How would our stack react to that? And yeah, it behaved as we hoped. It brakes for a leading car. And there's just one example of, if you define the project in a good way, it can be useful for a company really fast. Some words on how to create a successful PhD project. I guess I'm not the one to deem if it's successful, so I can just talk about how to make a happy PhD student. As I mentioned, I think a really good thing is to have a predefined first thing to work on. It's good if it's simple and then you get like an easy win. You feel, I know what I'm doing. I can go on for this for a few years. Or another alternative is maybe you join a senior student which has been working for a few years and can show you how research is done. I think collaborations are really great. It's much more fun to work with other people. So either within the company or with other universities. And this is also something maybe to keep in mind when designing a project, to find supervisors that align with those values. I think having engaged industrial and academic supervisors is really important. So like Christopher has part of his work time dedicated to actually supervise the students, so it's easy to get hold of him. Being flexible in the research directions, like AI is a fast-moving field. Like the project we wrote out in the beginning is very different from what I've actually been doing. So I think not being too locked down is very important. Being a bit opportunistic, like when a new technique comes out, try to integrate that. And then my personal view is you should probably limit the amount of company work you do that's not directly tied to your research. So like this last project, we of course helped the team to integrate it. And I mean, it didn't advance my own research, but it was sort of tied to research and I could see it the entire way. So it was valuable, but pure work that's not progressing your own disputation doesn't feel that valuable. So why join WASP? Again, it's a great way of doing this networking and finding different collaboration opportunities with these study trips and the summer school and so on. I also enjoy the WASP courses. It feels like they are very tailored to PhD students in a way that's like the schedule is very flexible. You can decide a bit yourself when you work on the different courses, so it doesn't interfere that much with the research. And actually 2 of the courses have been a very good fit with my own research, so they actually generated 2 papers. So it's very neat. You get your course credits, but also get your papers. And then if you like traveling, WASP is really great. You get your travel funding, so you can go to conferences. The study trips are great. And also longer research visits. Okay, yeah, that was all I had.